Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 5.4, Day 1, Solving Rational Equations. So now what we're going to do is we're going to take some of the ideas that we used in the last section, and we're going to solve our rational equations, okay? So we need to simplify. This is a review. Simplify each expression. Looking at this fraction, what I'm going to do is factor my numerator. So what multiplies to 8 that could add to 2? That would be 4 and 2. Well, I need that to multiply to a negative number, which means 1 needs to be positive, 1 needs to be negative, and it needs to add to a positive 2. So this would be positive 4 and negative 2 over x minus 4. At that point, I would look to see if I can cancel anything. There is nothing I can cancel. The last step that we always had was to state our restrictions. Well, our restriction would come from this x minus 4, so x would not be able to equal positive 4. Okay. On to the second review here. Again, I want to simplify by factoring in my numerator. So it's going to be generic factoring. So I would have x and x. What can multiply to 12 that could add to 8? Well, you have 1 times 12, 2 times 6, 3 times 4. Well, 2 and 6 would get us to 8. 2 and 6 would get us to 8. We need this to multiply to a positive number and add to a negative number, so they're both going to be negative over x squared plus x minus 6, again, is going to be generic factoring. So I'll have x and x. What can multiply to 6 and add to 1? Well, that's going to be 2 and 3. It has to multiply to a negative number, add to a positive number. So 1 needs to be positive, and one of them needs to be negative. Since it needs to add to a positive number, my larger will get the positive. Now I can go ahead and see if there's anything that I can cross out. The x minus 2 I can. So it would be x minus 6 over x plus 3. Again, I want to do my restrictions. So x minus 2 would get me x cannot equal 2. X plus 3 would get me x cannot equal negative 3. And I am done with that problem. Okay? All right, now we have the definition. Rational equation, an equation that contains one or more rational expressions. Remember from our previous unit that a rational expression is just a fraction. To solve a rational equation with only one rational expression on either side of the equal sign, what that means is that on either side of the equal sign, doesn't matter which side, if I do not have two fractions that are added or subtracted with each other, then I can go ahead and cross multiply. When I cross multiply, I'm going to multiply the 3x times the x, which would get me 3x squared. Now comes my equal sign. And then 9 times 3 will get me 27. Okay? I'll explain what extraneous solutions are in 1 second. Obviously, it says we need to check for them. Now, there's a couple different ways you can go about this. What I would like to do is use the same process every single time. So after I get everything set up like I have here, I'm going to bring everything to the same side of the equal sign. So I'm going to subtract 27 from both sides, which would leave me with 3x squared minus 27 is equal to 0. Now I'm going to look to factor. So the first thing that I can do to factor this is take out a GCF of 3, which would leave me with x squared minus 9 is equal to 0. Now looking at the x squared minus 9, I can break that up as the difference of two squares. So it would be 3, 2 sets of parentheses. An x would go in the front. I have to find the square root of 9, which is 3. Remember the difference of two squares. I'd have a positive and a negative. Now that I have this fully factored, what I'm going to do is set everything equal to 0. So 3 would be equal to 0. Since that does not true, I can go ahead and cross that out. X plus 3 will equal 0, and x minus 3 will equal 0. If I subtract 3 from both sides, x would be equal to negative 3. If I add 3 here, x would be equal to positive 3. Now, talking about the extraneous solutions, what we're going to do is we do have to state our restrictions. Well, our restriction in this problem is just with this x, which means x cannot equal 0. So I'm going to check my two answers. Is negative 3 a 0? No. Is 3 a 0? No. That means that both of my solutions are good. But if either one of those solutions was 0, then I would not be able to use it, and I would just have to cross it out. Okay? Looking at the next part, we cannot solve a rational equation such as 2x over 9 plus 9 over 12 equals 2 over x using cross multiplication. The reason why is because of this side of the equal sign. Notice there is two fractions that are added together. I can only have two fractions total. I cannot have more than two fractions and be able to cross multiply. Okay? So let's look at number 1. I'm going to take 5 times 3, which will get me 15, is equal to x times x plus 2. So 15 will be equal to, I'm going to distribute this x, so it would be x squared plus 2x. Remember what I said above is I want to get everything to the same side of the equal sign, so I'm going to subtract the 15 from both sides. So 15 minus 15 is 0, which would get me x squared plus 2x minus 15. And now I'm going to go ahead and factor. So 0 would equal, I can use generic factoring here. So x and x. What can multiply to 15? That can also add to 2. Well, that would be 5 and 3. Since it needs to multiply to a negative, add to a positive, I would have a positive 5, negative 3. Now that it's fully factored, I'm going to set each term equal to 0. So x plus 5 will be equal to 0. Subtract 5 from both sides. X is equal to negative 5. And x minus 3 will be equal to 0. Add 3. So x would equal 3. At this point, I need to go back and check my restrictions to see if I have any extraneous solutions. The only restriction I'm going to have is this x plus 2. So x plus 2 cannot equal 0, which means that x cannot equal negative 2. Well, I have negative 5 and positive 3, so both of my solutions here are good. Okay? On to problem number 2. I'm going to use the exact same process to start the problem off. So x times x minus 4. So I'll have x times x minus 4. And I'll have 3 times x. So it's equal to 3x. Distribute my x. So x times x is x squared. Distribute my x. Minus 4x is equal to 3x. Remember I said that I want to bring everything over to the same side of the equal sign. So I'd have x squared. If I subtract 3x from both sides, minus 7x is equal to 0. Now I can factor x squared minus 7x. So x times x minus 7 is equal to 0. Now that it's fully factored, set everything equal to 0. So x is equal to 0. And x minus 7 is equal to 0. There's nothing more I can do with x equals 0, but I can add 7 in the other side. So x is equal to 7. Again, I need to check for my restrictions. The only restriction I will have is from x minus 4. So from x minus 4, my restriction would be x cannot equal 4. Well, 0 is not a 4, and 7 is not a 4, so both of my answers are good. Okay? Let's go ahead and move on to the back. Problem number 3. I only have two fractions. I have an equal sign between them, so I can cross multiply. 5 times x plus 2, so it would be 5 times x plus 2 is equal to x times 7, which would be 7x. I need to distribute my 5, so 5x. Distribute my 5 to the 2, so plus 10 is equal to 7x. Again, I want to bring everything to the same side of the equal sign. So I'll subtract the 7x from both sides. So negative 2x plus 10 is equal to 0. I can take out a GCF from negative 2x plus 10. But I never want my x to be negative. Okay, I don't want my x to be negative. So what I'm going to do is take out a negative 2, which would leave me with x minus 5 is equal to 0. Now that I'm fully factored, negative 2 can equal 0. That's not true, so I can get rid of it. X minus 5 can equal 0. If I add 5 to both sides, x would equal 5. I need to check for my restrictions. I have a restriction from x, which is x cannot equal 0, and a restriction from x plus 2, which means x cannot equal negative 2. Well, 5 is not 0 or negative 2, so I am good. All right, on to problem number 4. Cross multiply. 2x times x is 2x squared, which is equal to 9 times 2, which is 18. Again, I want to bring everything to the same side of the equal sign. So if I subtract 18 from both sides, 2x squared minus 18 equals 0. I can take out a GCF between 2x squared and 18. It would be 2, which would leave me with x squared minus 9 is equal to 0. X squared minus 9 is the difference of two squares. So 2 times x plus 3, x minus 3. If you remember, on the front side, we had just taken care of the difference of two squares with x squared and 9. So that's why I did not go over it again. Now that everything is fully factored, I'm set equal to 0. 2 would be set equal to 0. That's not true, so I can get rid of it. X plus 3 is equal to 0. Subtract 3 from both sides. X would equal negative 3. X minus 3 is equal to 0. Add 3 to both sides. So x is equal to 3. I need to check for extraneous solutions by looking at my restrictions. So x cannot equal 0. Well, negative 3 is not 0, and 3 is not 0. So I'm good. On to problem number 5. Again, I only have two fractions. I have an equal sign, so I'm going to cross multiply. It would be 8x times 4x plus 1. 3x times 6 would be 18x. Well, 8x times 4x would be 32x squared. 8x times 1 would be positive 8x is equal to 18x. Remember, I keep saying I want to get everything to the same side of the equal sign. So if I subtract 18x from both sides, I would have 32x squared minus 10x is equal to 0. Now that I only have two terms, I want to factor it. It would either be the difference of two squares, or I can take out a GCF. In this situation, I could take out a GCF of 2x. Would leave me with 16x minus 5 is equal to 0. I'm fully factored, so I can go ahead and set 2x equal to 0. Divide by 2. X equals 0. And 16x minus 5 is equal to 0. Add 5. 16x equals 5. Go ahead and divide by 16. So x equals 5 over 16. Now again, I have to check my restrictions. So 3x cannot equal 0, right? Which means that x cannot equal 0. And then I need to look at 4x plus 1. Well, if 4x plus 1 cannot equal 0, subtract 1 from both sides. 4x cannot equal negative 1. Divide by 4. X cannot equal negative 1 over 4. So I need to check my two answers to see if either one is 0 or negative 1 over 4. The first answer I come to is x is 0. So that will not work because that is one of my restrictions. So that answer is gone. The second answer I have is 5 over 16. Well, that's not 0. That's not negative 1 over 4. So 5 over 16 is a good answer. Okay? On to problem number 6. I only have two fractions. So I'm going to cross multiply. So I'm going to have x plus 12 times x plus 2 is equal to 3 times 2x plus 3. X times x is x squared. X times 2 is 2x. 12 times x is 12x. And 12 times 2 is 24. You could at this point go ahead and combine like terms, the 2x and 12x, if you want. I'm not going to at this second, but I'm going to go ahead and distribute on the other side of my equal sign. So 6 times 2x, or 3 times 2x is 6x. 3 times 3 would be 9. All right. Now, I need to get everything to the same side of the equal sign. So x squared plus 2x plus 12x is 14x. Minus 6x. Okay. I'm going to subtract the 9, which means 24 minus 9 would get me positive 15. Well, 14 minus 6 will get me 8x. So I have x squared plus 8x plus 15 is equal to 0. From here, I can use generic factoring. Two sets of parentheses, x and x. What multiplies to 15 that can add to 8? Well, it's 5 and 3. Both addition. Set everything equal to 0. X plus 5 equals 0. X plus 3 equals 0. Subtract 5 from both sides. X equals negative 5. Subtract 3 from both sides. X equals negative 3. I have to check my restrictions. I have this x plus 2, which means x cannot equal negative 2. Well, negative 5 and negative 3 are not negative 2, so they are both going to work. On to problem 7. Exact same process again. I only have two fractions, so I'll go ahead and cross multiply. So I have 9 times x minus 1 equals 4 times 3x would be 12x. So it's 9x minus 9 is equal to 12x. Get everything to the same side of the equal sign. So I have negative 3x minus 9 is equal to 0. Again, I can take out a GCF, and I do not want my x to be negative. So my GCF would be negative 3, which will leave me with x plus 3 is equal to 0. Now that I have it fully factored, negative 3 is equal to 0. That's not true. X plus 3 is equal to 0. Subtract 3 from both sides. X is equal to negative 3. I have no restrictions, so I only have 4 and 9 in my denominator. So my answer is good. On to our final problem. 2 times 2x plus 5 is equal to 6 times x plus 2. So 2 times 2x is 4x. 2 times 5 is 10. 6 times x is 6x. And 6 times 2 is 12. Again, I want to get everything to the same side of the equal sign. On this problem, I'm actually going to move the stuff on the left over to the right just because everything on the right is larger and it'll keep my x positive. So I'll subtract the 4x over and I'll subtract the 10 over. So leave me with 0 equals 6x minus 4x is 2x. 12 minus 10 is 2. Now I can take out a GCF, so 0 equals 2 times x plus 1. I'm fully factored, so 2 would equal 0. That's not true. X plus 1 will equal 0. Subtract 1 from both sides. X is negative 1. Need to check my restrictions. From x plus 2, I would have x cannot equal negative 2. From 2x plus 5, let's go ahead and work through that one. Subtract 5 from both sides. 2x is not equal to negative 5. Divide by 2. X is not equal to negative 5 over 2. Well, my answer of negative 1 is fine because it's not negative 2. It's not negative 5 over 2. So negative 1 will work. Remember, from this lesson, if I have two fractions, just two fractions total, on either side of an equal sign, I can go ahead and cross multiply. Once I cross multiply, I distribute everything out. I want to bring everything to the same side of the equal sign. At that point, I can factor to solve for my variable. If you have any questions over this unit, or this section, please come in and see me. Don't wait 2 or 3 or 4 days. Come in right away. Let's get day 1 in your head. Let's get this hashed out right away so that you are ready to move on when we move on to day 2. Well, thank you very much for watching this video, and have a great day.